Hello friends, SMPS or switch mode power supply is very important and crucial part of any electronic project. Most of the time we use the ready-made power supply available in the market, but sometimes power supply of required specification is not available in ready-made. So it will be a wonderful idea if we make our own power supply. We always think that it is very difficult to make SMPS, but actually it is not. After watching this video, you will be able to design and make your own power supply with your own specifications. In this video, we will see the easiest way of making the switch mode power supply. So let's start making. While searching online, we found different websites which offers to make the design of SMPS with our own specification and ratings for free. Like eDesign Suite of my.st.com website from ST Microelectronics, or flyback SMPS design tool of nxp.transsim.com website from the NXP Semiconductors. Or we can use PyExpert online tool on pyexpertonline.power.com website from Power Integrations, which gives us the opportunity to design our own SMPS power supply of customized input and output specification online for free. In this video, we are going to use the eDesign Suite from the my.st.com website, and we are going to make the 5V and 1A power supply. We will demonstrate the entire process of making the SMPS power supply. So thereafter you will be able to make the SMPS power supply of your own specifications. Here it is, I have logged in eDesign Suite. To design the SMPS, click on Converter, then AC to DC. Then I am going to select Isolated, and then out of FF flyback and QR flyback, select QR flyback type design. Now we will choose the input. You may select the custom and write down the minimum and maximum input voltage. Or you may select the predefined voltage range, like I am going to choose the European range 50 Hz. It gives minimum 185 and maximum 265 volt automatically. Now we want to design the output 5V and 1A for this power supply. So write down the values. You can see it shows that the output power is 5W. Here we will choose the switching IC. I will select the ALT-AIR04-900 IC. Now we have given all inputs and we will click on Start Design. This design tool will start processing. After a minute or two, the processing will complete. Again, it is showing the details of mains input power supply and the details of output. Click on Automatic Design. So it will complete the design automatically, and here it is. You can change some of the components if you want, like you can change the clamper net. Options are RCD based or transil based. It is already RCD based, so you can change transil based. Here you can see the transil based design. Similarly, you can change the transformer core. In automatic design, it is showing E16S, but if you want to change, you can change, and click on autocomplete and redesign the circuit as per your selection. For this SMPS, I am going to select the RCD based clamper design, and I am going to use the E19 core for this project. You can see a lot of different options for the transformers are available in the list. I am going to select EE19 horizontal core. Here it is, the EE19 horizontal core. Select it and now click on autocomplete. So after completion you can see the circuit design. You can see the schematic or BOM from there. You can see the BOM, the list of components is there. To make the transformer, you can see the details of the transformer. How many turns are to be there and what type of wire we are to use in making the transformer. All the details are available there in this window. Now we are going to make the switch mode power supply. First I'll make the circuit in Eagle and design a PCB. As per the design, I have made the circuit in Eagle. Here it is, the PCB design. I have made the panel of the PCB and sending to the manufacturing facility. I am also going to place the order for the components. Within a few days we will get the PCB and components, then we will further go ahead with this project. Here it is, all the components which I have ordered for making the power supply. Here it is, the PCB which I have received. To make the transformer, here it is EE19 ferrite core. And it is the horizontal bobbin. I am not having enameled wire as per the specification of the E-Design suite. I am having a 36 SWG wire. I am going to use this wire to make the transformer. For the secondary coil, I'll fold it in multiple and make a multi-stand Litz wire. And for primary and auxiliary coil, I'll directly use this wire. Now we will open the PCB package and let's see how it is. Here it is, you can see the PCB panel looking good. Let us separate the PCB from panel. Here you can see, by using this PCB we can make a wide range of different SMPS just by changing the components. This time we are making a 5 volt and 1 ampere power supply. So I'm going to solder all the components on the PCB and let's see how it works. Here it is, I've soldered all the components on the PCB. Here you can see the remaining thing on the PCB is the transformer and output terminal block. Now I'm going to make the transformer for this power supply. Here it is, the details of transformer. I'm going to use EE19 core. As per the design, in primary there is 138 turns and in auxiliary there is 28 turns and in secondary 10 turns. In secondary coil we will use Litz wire by multifolding an enameled wire. Litz wire is typically used to improve efficiency of high frequency transformers and carriers AC currents at radio frequencies. Another important thing we take care is the direction of the coil. You can see the dot. It shows that the direction of the primary coil is in opposite of the secondary and auxiliary coil. So while making the transformer windings, we will take care of the direction of the coil. Now you can see the bobbin. There is a dot marking, which is an indicator. I will hold this dot in this way and put all the turns in this way. I'll hold the bobbin in this way, so the dot indicator will be towards my left thumb. The marking is towards my thumb and I'll put all the turns in this way. But what I'll do for the primary coil is that I'll change the pin sequence. First I will connect the wire from pin number 2 and then I will put the turns in this way, and at last I will terminate this coil at pin number 1 of the bobbin. For auxiliary coil I will start from pin number 3 and again I will put the turns in the same direction, and finally I will terminate this coil on pin number 4 of this bobbin. In this way the direction of the coil of primary and auxiliary will be different. Similarly I will make the secondary coil. I will start the secondary coil from pin number 6 and then I will put the turn in the same way and finally terminate the secondary coil on pin number 5. So in this way I will prepare the transformer. Now I'm going to make the primary, so first I'll twist this wire at pin number 2. Then I'll start. As I told you, this is the indication over there, and I'll start in this way. I'll put 138 turns in this way. Here it is done. I have terminated the coil on pin number 1. So I have done with the primary coil. Here you can see the primary coil is complete. Now I will put tape on it. Here the primary coil is complete. I'll start working with auxiliary coil. As per the design, we are to put 28 turns and we will start from pin number 3. It is the marking, so in this way we will put the turns. Here it is, 28 turns are done. Now we will terminate it at pin number 4. I am putting some tape on auxiliary coil. Here it is done. You can take a closer look. After primary and auxiliary winding, we can start the secondary. In the secondary winding, we are to put 10 turns. So for that, I have made a leads wire using multiple core of 8 wires. I am going to twist them all. Here it is, I have twisted the wire, and now I'll start secondary winding. I'll put 10 turns, start from pin 6. Here it is, the marking. It is done, and I am terminating it at pin number 5. Here it is done. Now I will cover it with tape. It is done. Now I'll solder the wires with the pin and cut the extra length of the wire. Then thereafter I'll put the ferrite core in the coil. Then the transformer will be ready, and I'll put tape on the core. You can see the transformer which I have prepared. Now the transformer is fully ready to solder on the PCB. Then thereafter we will see how the power supply performs. Now it is fully ready to test. Let's check its dimensions. You can see the length is 49.4 mm. Width is 24.6 mm. And the height of the SMPS is 14 mm. The power supply is very slim, compact and looking good. Now we will do the load test of this SMPS and see its performance. Here it is, I have connected my SMPS power supply for the testing purpose. You can see I have connected it with the load. This load is made by us. If you want to see the details and video of making, card is available in the top right corner of this video. You can see the video of the making of this electronic load if you want. I have connected the AC mains power supply with this SMPS power supply. You can see, and you can see a bulb is also connected over there. This bulb acts as a fuse. So I have connected this bulb like that, the AC mains power supply phase directly comes in this bulb. From there you can see, and then one wire of this bulb is directly connected with the phase, and another wire from this bulb is connected to this SMPS power supply, and neutral is directly connected to this SMPS power supply. So this bulb is in series of the phase and it will react as a fuse. So if the SMPS will work properly, then this bulb will glow very low. But if there is any issue with this SMPS power supply, this bulb will start glowing brighter and it will show that the fuse is blown, but actually it will not blow, it will just start glowing. But in case of this bulb, if we use the fuse, then it will surely glow. So let's see how this SMPS power supply works. So I'm going to power on this SMPS power supply, and then we'll see after giving the load how much load it can take, and we can check the voltage using this multimeter. So first I'll power on this SMPS power supply. Here it is, the SMPS power supply is on, and you can see the load is 0 and the voltage it is showing, but we'll also check the voltage from this multimeter. So I'm going to test the voltage. I'll put the knob to check the voltage. I'll put it over there and let us check the voltage from the multimeter. You can see the multimeter is showing 5.12 volt. This time the voltage is also 5.1 over there in display, and load is 0. Now slowly we will increase the load and we'll see how much load it can be able to take. We'll also see how the voltage gets changed. We increase the load. So just I'm going to put this multimeter here so you will be able to see the display properly. Hopefully you are able to see the display. It is 5 volt, 5.1 volt. Load is 0, so slowly we'll increase the load and we'll see the voltage and current. You can see the load is about 100 milliamperes and it is giving us precisely 5 volt. Load is about 100 milliampere. I'm going to increase this load further. Here it is 220 milliampere load, and the voltage is 5 volt. See, further we'll increase the load. See, it is now about 500 milliampere. You can see the load is 500 milliampere and the voltage is still 5 volt, very much stable. Now I'm going to increase the load further. I'm showing this bulb also. It is glowing, but very much slightly, because very few milliampere current is flowing in this filament, that is AC, of course. So now further we increase this load and you can see this time it is 600 milliampere, still stable. This bulb is start going a bit more. Now further we'll increase the load. Now it is 700 milliampere, 7.27 milliampere. Voltage is still very much precisely 5 volt, and the load is 7.27 milliamp. And you can see this bulb is start glowing a bit. So AC, it is taking more AC current for the 7.27 ampere, 0.727 ampere load. And as I told you earlier that this power supply is 5 volt and 1 ampere design. So let's see how much actually it is going to deliver us. Further we are going to increase the load, and now it is 800 milliampere, and you can see this bulb is glowing and flash is showing that the fuse is blowing, and the voltage also goes to 0. So we'll reduce a bit. We'll reduce the load a bit, and now we have kept this load at 800 milliampere, and you can see at 800 milliampere the voltage is very stable, that is 5 volt, and it is giving us 800 milliampere current. And further if we increase very slight, it is sustaining, but let's see how much it can deliver us. Slightly we are increasing, but now bulb is flashing. You can see voltage goes to 0 and load also goes to 0. It's showing that its maximum capacity is 800 milliamp in practical. So here it is, the SMPS power supply which I have designed and developed as per the e-design suite available online. We are not getting output 1 ampere as per the design. It is because of the tolerance of the components, and I have not made the transformer as per the prescribed specification. So this SMPS is giving maximum 800 milliamperes. Hope you like this video. Click on thumbs up, like, share and subscribe this channel. Click on the bell icon for the notification of new video. Thanks for watching.